An isosceles triangle of points x, y, z, where x, y is equal to zx, which is equal to 5.9 centimeters, and yz is equal to 5.0 centimeters, determine the measure of the angles of the triangle to the nearest tenth of a degree. So what I did was I drew the triangle, as we have our isosceles triangle with two equal sides and one uneven side, and we're asked to determine the angle of x. So what we need to do is we need to, and I made all the substitution. I made this side equal to A, B, C, and we'll make that angle equal to A. So what we're going to do, is use a cosine law, which is C squared is equal to A squared plus B squared minus 2AB cos of x, and we're going to solve for the angle of x. So before I do anything, I want to isolate the x algebraically. So I'm going to subtract both a squared and b squared to the other side. So actually, before I do this, I'm going to say that a squared plus b squared minus 2ab cos of x is equal to c squared. So we can kind of solve for the left side. So we're going to subtract a squared and b squared. That gives us negative 2ab cos of x is equal to c squared minus a squared minus b squared. Then now I'll divide both sides by negative 2ab, negative 2ab. So cos, you know what? I'll just solve for x. So x will be equal to the inverse cos of c squared minus a squared minus b squared over negative 2ab. So if I make all the substitutions, so x is equal to inverse cos of c squared, which is equal to 5, that's going to be 25, minus a squared, which is 5.9 squared, minus 5.9 squared, which is b squared, over negative 2a, which is 5.9, b, which is also 5.9. And if we plug that all into our calculator, it'll give us x is equal to inverse cos of 0.64, which gives us a degree of 50.1 degrees.